And that was our first meetup where we had like about 110 registrations and pretty great number of attendees. So like about 90 attendants came. And I remember that they were really impressed about the session that Dave gave. And now that's 2025. We are starting our second year here in Calgary. And again, Dave is starting our year with a great topic, and thank you for that. Yeah, a couple of words. Dave is a principal software engineer in Microsoft. I'm not really good in saying a lot of great words about the specialists and other stuff. Well, sorry, that's the lack of my English at this point of time. Yeah, but let's welcome Dave and with this great session about the Playwright.
Thank you.
David.
Thank you so much. It's so great to be back here, and it's such an amazing community. I love how you guys do these icebreakers and these testing scenarios. It's super interesting seeing where your minds go with testing these really unique things. Okay, so this was actually the session when Lavanya reached out to me a year ago to do the first one. The thought was that I was going to do this Playwright session, and I kind of suggested another topic of something that I had wanted to present about, which was how we do testing at Microsoft internally, at least within the groups that I'm involved with. So here I am back now to do the original presentation that you asked me to do, and in a way I'm kind of glad that we waited, because Playwright is continuing to evolve and there's lots of cool new things, so this gives me an opportunity to chat about like a couple of those new things that I'm pretty excited about. So as Kate said, I'm Dave Paquette. I'm a software engineer at Microsoft. I work on the Azure DevOps team, which is if you're not familiar with it, it's a tool that you can use for managing your software development projects, has Git repos in it and work item tracking and a lot of other features, including test case management, which may be of interest to people in this group. Playwright is also a Microsoft product. I don't work and I'm not really associated with the Playwright team, but we do use Playwright very heavily internally to do testing at Microsoft, and we happen to use it on our product as well. So first of all, let's take a step back and talk about like what problem Playwright is trying to solve in the first place. And that is end-to-end testing. So the idea of testing the software as closely as possible to the way the users actually use the software. So launching the software and like clicking buttons and entering things and like interacting with it like a user, and having like the full system there. The database is there. You're pulling live data from a real system. It's a full end-to-end, front to back end test of the system. And this idea has been around for a very long time. I have attempted end-to-end testing at a lot of companies where I've worked in the past. The kind of original tool in this space, when we're talking about end-to-end testing in like a web application, would be Selenium. Has anybody had experience or used Selenium for testing? There's a few people, yeah. Was that like a good experience for you in general? Yeah, kind of mixed, like, yeah. That's kind of my experience too. So I did there was a big product that I was working on in Calgary here for a local company, and I onboarded the team to doing end-to-end testing. We were using Selenium, and we built up like a pretty big test suite that would run automatically with every pull request we would have to the code base. And like it had a lot of value because it tested a lot of really complex scenarios. And it did that in an automated way, and it was like repeatable, but the tests were like super flaky. And after I left the company and I came back like a year or so later just to visit and chat with folks there, and I asked like, how's that test suite going? Like, you know, and the guy said, it's pretty good, but we've never had a successful 100% pass on all of our tests on a test run. There's always like a test or two that ends up failing randomly, and then you rerun it and it's fine. said it happened once. We had 100% test failure, like one time when you were still there, and I think it was a fluke, he says. So it's like there's a lot of value there, but with that flakiness, it's really hard to realize that value because you can't trust the results of the test running. You waste a lot of time investigating, is this a real failure or is this just like some transient flakiness inside of the tests themselves? So Selenium, as I said, that's kind of like where this all started. And there have been many iterations after that. There was something called Phantom.js that attempted to run the tests a lot more quickly by running in a headless browser, and it did that by taking a fork of WebKit. It did that like 9 or 10 years ago, and it hasn't been updated since then, so it's kind of like dead now. So if you have all these tests written in Phantom.js, you're testing in a browser that doesn't really exist anymore. So that's not great. Protractor was a test tool by Google for Angular applications for doing end-to-end testing. And it simplified a lot of like the setup around that happens around Selenium and like getting it to be set up and work. And it added some really nice syntax for testing in the context of your Angular apps. But it was still sitting on top of Selenium. So you still like suffered from a lot of that flakiness. And then Cypress was kind of the first one that took a different approach and branched out from Selenium and like a lot of the other tools that were built around Selenium. Anybody use Cypress here? I suspect there's been some, yeah. And how's that experience been? Better, a little bit better, yeah. Like Cypress is pretty good and very popular. A lot of people have lots of big test suites run on Cypress, and there's really good community around it. It's a really good tool. Another one is Puppeteer. This one was created by Google, I think like 2017. And it was very Chromium focused or Chrome focused because it came from Google. And that was the main thing that they wanted to test. And again, quite good. Introduced some new APIs and ways to interact with the browser to simulate user interactions. And then fast forward like a few years and Playwright was created. And it looked a lot like Puppeteer at the time, and it shared some of the APIs and looked pretty similar. And the reason for that is that it was created by, so Puppeteer was created at Google by some engineers at Google, and Playwright was created at Microsoft by some engineers at Microsoft. But some of those engineers were the engineers who previously worked at Google and built Puppeteer. So they took some of those ideas and they wanted to take what they had started there, and it almost in some ways feels like a next version of what was started in the Puppeteer world. But it started out with some ideas that like bigger problems that they wanted to solve. So they wanted it, first of all, to be cross-browser. So not just Chrome. They wanted it to test all browsers that people use anyway. And they wanted it to really be resilient and really address this flake test problem. And I'm gonna poke a little bit of fun now at the marketing page, like the landing page for the Playwright website, playwright.dev. The website itself is fantastic in terms of the documentation and everything, but I just like to poke fun sometimes at the marketing side of things. So it makes some pretty bold claims on the website. And we're gonna go and break those down just so that we understand what they actually mean by some of these claims. So the first one was the cross-browser, cross-platform, cross-language. And then the next big one is that it is resilient. You get no flaky tests and there are no trade-offs. And then finally, the powerful tooling. So let's chat a little bit about those. So first of all, what does cross-platform mean in the context of this tool? So we're talking about testing in web applications. So when we say cross-platform, or cross-browser, we're meaning like the different browsers that people use. So we've got Chrome and Edge and Firefox and Opera and Safari. But what do 3 of those have in common? Anybody? No? They're Chrome. They're all Chrome, right? So Chrome, Edge, and Opera are all built on top of Chromium. So they're actually the same rendering engine. So those are really mostly just one, although you can test like the individual implementations of it. And then we've got Firefox, which is its own engine, and then Safari, which is WebKit. So we test on the WebKit open source implementation, not actual Safari. And then when we talk about cross-platform, we're really talking about a bit of a subset of cross-platform here because we're talking about desktop operating systems. So it's a tool for testing web applications on the desktop. So we've got Windows, we've got Linux, and we have Mac. So that's what we mean by cross-platform. You can still simulate inside of those browsers a mobile device, but it's not exactly the same as like running it on an Android or an iOS device. And finally, cross-language. And this one's actually like pretty cool. You can pick whichever language is appropriate for your team. You can do Node, so like JavaScript or TypeScript. You can do C# with .NET. You can do Python, or you can do Java. Really, is just choose whatever is appropriate for your team, whatever they're most familiar with. Although I usually try to guide teams, if they know JavaScript or TypeScript, towards that version, because that is more the native version of the tooling. So you get a little bit of a better experience there. With the other implementations, it's like a language binding that's sitting on top of that. So I tend to use TypeScript or JavaScript with my tests. So this is a big claim here, is that we're not going to have flaky tests anymore, right? So when I asked how people's experience was with Selenium, it was like, it's that flakiness that's an issue. So flaky tests where you run your tests once, it passes, you run it again, it fails, you run it again, it passes, and you can't really trust the results. It's a problem. And they're saying that they've solved that problem. So just to set the expectation there, like, you're still probably going to have some flakiness because this is a really hard problem to solve. And if you structure your tests in the wrong way, you will have flakiness. But it is possible to write much less flaky tests, or you will have fewer flaky tests, or the flakiness won't hit you as often when you're using Playwright if you're using it properly. So one of the main reasons why these web tests fail is because the DOM just isn't ready yet. So the document object model, the thing that is representing in your UI inside of the browser, just isn't ready to be interacted with yet for whatever it is that you're trying to do, whatever action you're trying to perform. And in the past, we solved this by adding artificial weights randomly in the code. Well, not randomly, but like in places where we thought we needed it in the code. So we'd say like, wait 5 seconds, then try to click here. And if it doesn't work, maybe wait like a little longer. And then if it doesn't work, then fail the test. And it didn't ever really work 100% of the time. And it also made our tests really slow because we had these weights everywhere in there, just specifically for the goal of trying to avoid having these flaky tests. So Playwright was built with this in mind. It's built for the dynamic web. So all of the assertions that you make and the checks that you make and the interactions that you do, like clicking and entering text and whatever else you might be doing, dragging and dropping things, it has a certain amount of weighting built in that it just kind of knows by listening to the event pipeline of the browser itself. It knows when it is an appropriate time to try the first time. And then it also has that like wait and retry logic built in already, so that you don't have to write that into your test framework for yourself. So you can configure test retry strategies as well. And you can capture traces and videos and screenshots that will help you to eliminate those flaky tests when they do happen, because it's still going to happen. The difference is that you have tools at your disposal now to help figure out what happened, and a framework that's built in a way that you can structure the tests so that they aren't flaky. All right, next fun little claim is that there are no trade-offs and no limits. And I've not ever chosen a platform that has no trade-offs and no limits. But I dug into this one a little bit more and kind of found that this was like kind of really specific about some of the trade-offs and limits that they had in the Puppeteer framework when they built that one. So specifically here, it's that we can write tests that are multi-tab. So we're not limited to like just a single tab instance of the browser. We can go multi-origin and multi-user very easily, whereas that was like pretty hard to do previously. So multi-origin meaning like the app you're testing is on a certain domain, like myapp.com. And maybe for part of your test, you need to go to like some other website to go do something and then come back to it and get redirected back. Like maybe your auth, for example, if you need to sign in, you go to like some other authentication system and come back. those scenarios were like really hard to write previously, and that is solved now in Playwright. So the other one is that the no limits part is just more around like it's using that real browser input pipeline. So we're just like a little bit closer to how the user actually interacts with the browser, which is great because that's like the original goal, was to try to test the way the user uses the application. Cool. Full isolation and fast execution. Okay. So thinking back to like my previous experience with testing, and how the tests would be like super slow, and the reasons why it was slow, or the reasons why things would fail, is because you sometimes didn't, like, you want each individual test to be isolated so that it isn't affected by like some other test that might be running at the same time, or the order that your tests happen to run in, that kind of thing, right? You want that isolation for every test that you run. And the way to accomplish that in a browser is to create an entire new browser context, which is like the equivalent of creating a whole new browser profile, not just like a new browser tab, but a whole new browser profile. It's completely isolated. But that's traditionally been very expensive to do. So with other tests, to speed them up and make them run in a reasonable amount of time, you would like share a browser context, which would then lead to more flakiness. So it was like this trade-off that kind of sucked. With Playwright, they've made it so that every test gets a new browser context, just automatically. That's how they work. They get full test isolation, which is great. And it says with zero overhead, which sounds impossible. How can they do that? They follow up by saying that creating a browser context only takes a handful of milliseconds, which is like a really odd unit of measure for milliseconds. I don't know how many milliseconds fit in my hand. But in practice, from using it, it is like negligible. Whatever it takes to create a new browser context and run a new test, it just doesn't matter. That's the whole point. So that's great. And the other thing is being able to log in once. So having a new browser context is great, but then if you have to go and like replay your login scenario just to get to the point where you're logged into the app to do the thing you wanted to test, then it's going to add like possibly 10 seconds to your whole thing, right? To your whole test, each individual test. So they have a really cool way of solving that, where you basically at the beginning of your test suite, you will do whatever login sessions you need to do for the different types of users that you want to test as. And you save that authentication state off into a file. And each test, you just tell it which profile to use, which authentication state to use. And it loads that up like really fast. So you don't have to replay that login piece every single time. So that's another thing that like makes it really fast while still getting that isolation. But the thing that really got me excited and into Playwright in the first place was the tooling. So it has super powerful tooling around code generation. We have this thing called Playwright Inspector, which is actually the thing that you use to do code gen and a bunch of other things, and a trace viewer. So the easiest way to show this is to actually just go into a demo. We'll test like a real app and show you how these tools work in practice. So I am going to have a seat now. All right, so I'm going to demo using Playwright to test this app that it's now a defunct open source project, but it was a system around helping families to become prepared for emergency scenarios that are common in their, or could happen in their particular place where they live. So it was a project we did with the Emergency Response Division in Washington State. And the application itself is a web application built in Vue.js. It's intended for mobile phones, so like it would look more like this in theory. But we're on a desktop today, so it looks like this, which is a little weird. But it has, there's several components to this. So there's a backend that's written in Azure, using Azure Functions, and I have it running locally already. So that's like our API, the REST API that we're calling. And then it's interacting with Cosmos DB to get data. So there's a document database there where it's getting and storing data. And then the front end written in Vue.js here, which, oh, went too big. I already have running. So the point is I have, it's, you know, there's multiple components to this application. I have them all running locally so that I can test it out. And I'll just show you some of the basics. So there's like, you can click in here and learn about all of the hazards in your area. There's actually like 10 other ones in Washington State because they have a lot of natural disasters in that area. It tells you generally what you would want to do in the case of an earthquake, how to prepare, what you should do as a family to be prepared before, what to do during, what to do after, and some resources. And then there's tools in here to go and create a family plan and build emergency kits with recommendations of like what would go into an emergency kit, how many things you would need to be 2 weeks ready, which is the name of the app. Okay, so that's the general idea around it. And let's just take a look at what it takes to test that with Playwright. So I already have some tests set up, but if I wanted to get started and I didn't already have this in my application, I would just be adding the Playwright test NPM package to my project. And I've already done that. And I have a couple tests written here under my tests folder. So I test the hazard info area that we just looked at. And I have also this welcome screen, which actually we're just going to take a look at by launching Playwright test here and taking a look at the Codegen tools. So that's how I got started with it, was using Codegen. All right, so the other thing that you need to do is run npx playwright install. And I've already done that, but that's the thing that goes and installs the local instances and versions of the browser that you're going to test with. So that's already there. And now I'm going to be using the Playwright. I'm going to be using the Playwright command line tooling today. There's also tooling built into like Visual Studio Code and other ways that you can interface with this. I'm a developer, and this is just like the tooling that I use. So to get started, I just did npx playwright codegen, which launches an instance of Chromium for me and launches the Codegen tooling so that I can go and play out a scenario just by clicking through the UI and look at the code that it generates. And that's like my starting point for my test. And I see that I'm disconnected from the internet now, which is probably not ideal. There. Okay, so it launches, but I didn't tell it where to go. So the first thing I'm going to do is go to localhost 8080, which is where. So there's my app that I have running, same one I was showing you, but I'm not logged in yet. So I'm getting like this welcome screen, and I can go like next, next, next. Tells me more about the app and what it's about. And then eventually, after I go through the kind of like welcome wizard, it takes me to the login page. So this is where now we're going cross-domain. It took me to auth0, where I'm actually going to go and attempt a login. You can see that as I'm hovering over, it's highlighting the element that I'm interacting with. And it's giving me, this is going to be hard to see, maybe I can zoom in, but you can see that it has a little tooltip there. It says get by label email address. So this is a really important concept inside of Playwright. That's called a locator. So locator is the way that you interact with the things in your UI. It's the way that you tell it, I want to either perform an action on here, like click. So I'll say locator.click, or I'll say locator, I'll write expectations or assertions on that locator. So I'll say expect locator to be visible, or expect locator to have text. And that's how we write our tests. We interact with these locators, and we write assertions against the locators. That's it, pretty easy. And with the Codegen tooling, it's really easy to get started. So here I'm going to go and log in, and I'll put in a password that isn't my real password, because I'm definitely not putting that in here. And now over in this Playwright inspector that it opened up on the side, it shows me the test code. So it says, go to that page, and then I click the next button 3 times, and then I clicked on the email address button a couple times, which was probably not necessary. Then I filled in my address, and then email address, I pressed tab, and then I filled in a fake password. And if I hit continue, it will tell me that it was the wrong email and password, and maybe that's a scenario that I want to test, right? So I would want to probably check that we got this piece of text here that said wrong email or password. So I could assert visibility. I could click on that and click on that little guy and zoom back out, take a look here, and we could see one of those expectations that I mentioned before. So here we're saying expect the locator, page get by text, wrong email or password, to be visible. And you'll notice that all of these things inside of the generated test code have this, the test itself is async, it's asynchronous, and they all have awaits on them. That's important. If you don't put them on there, you're definitely going to have some flaky tests and weird things happening. But the reason it is that way is that all of these actions, like the clicking and the go to a certain page and click on a locator, or the expectations that we have on locators, all have that built-in retry mechanism and wait for the DOM to be ready. All those things that we talked about earlier that help us to eliminate flaky tests. That's all built in there, and that's why it has to be awaited. So it's not an action that's just going to happen right away. It could happen within a couple milliseconds, or it might take half a second or a second, depends on your UI and how slow it is and what's going on. Up at the top, we have the target set up. So the default is the Node.js test runner, but maybe I want to write this using C#, and it gives me the C# MS test code for this test, or I could do it with Python or whatever language, as I said, is most appropriate for your team. So that's the Codegen tool, and that's like kind of how to get started with it. But I already have a suite of tests, as I said, and we'll take a look at them a little bit more in a bit. Actually, let's take a look at them a little bit right now. So the first one I have is the welcome page accessibility test. So I'm a big proponent of accessibility testing in general, but automated accessibility testing especially, because while it can't eliminate all of your accessibility problems in your application, there is really good automation in place that can eliminate like a whole subset or a whole class of types of accessibility problems inside of your applications. And it's like pretty low effort to add it if you're already doing automated testing. So what I'm doing here is I'm using Playwright, Axe Playwright. That might not, the Playwright documentation will tell you which is like the right library to use. This might actually be an outdated one, but the same concept applies. So all I'm doing inside of this test is saying, first of all, remember that thing where I said we reuse the login for users? With this one, I'm telling it to use the storage state for new user storage state. So this is going to the browser as someone who hasn't logged in yet, because that's a scenario we wanted to test. Most of my other tests are written around a user who has logged in, but and that's my default, just like a standard user who has logged in. In this case, I'm telling it for this test, use this particular storage state. And that's just set up in like my global setup. And we can take a peek at that later if that's of interest. But what I wanted to show here is with this test, all we're doing is before every test, because I have a couple of tests here, we simply launch the browser, go to a new page, the localhost 8080, and we go to the welcome page. And then we inject Axe. So that's the thing that I imported from the Axe Playwright accessibility testing library. And then I have this test called check accessibility. And all it does is I call check Ali, or A11Y, and I tell it what options I want to check. So I'm mostly just using the defaults, and then I tell it to give me a detailed report if anything fails. So that's it. Like to do the automated accessibility testing, all I had to do was call one function after going to the page, and it will run through that set of rules for you. And the other one I have is just that the welcome page actually loads. So page go to the main page, and that when I do that, I expect it to take me to the welcome page because I'm a new user and I've never been there before. Those are the two scenarios that I'm testing here. And let's go see what it looks like to actually run these tests now. So heading back over to my command line, I'll jump out of the Codegen here, and I can do npx playwright test. And that's going to go run my tests. And by default, what this does is it's going to run them in a headless state. So that's where there's no UI actually visible, but all the same rendering and everything is happening. It's just not visible to us as the people running the test, which is good because eventually we want to run these on like a build server somewhere in an automated way where it's not just like on my developer machine. So here we see we had my 3 different tests all ran and they all passed, but I have no idea what happened there. Sometimes it's interesting to actually watch the tests run, and maybe you just want to like focus in on a single one. So let's say that we look at, well, the welcome page ones doesn't actually do anything. It just goes to the page and checks some things on the page. The more interesting one is this hazard info one, where it's actually doing some work. So I can run just that test, but run it headed so that we can watch what it looks like. So now it's going to launch, because I have it configured only to test with Chromium by default. It's going to launch an instance of Chromium, and it's going to run through that scenario, and we'll see it actually run through that scenario. So here it goes. It's pretty quick. It kind of flashes on the screen, does a bunch of clicking, and then we're done, right? That was just with Chromium. What if I wanted to run it in Firefox now? So I could say browser equals Firefox, and it would run it in Firefox, and that would be cool. But even more cool is if I just run them on all the browsers. So now it's going to run it on Chromium, WebKit, and Firefox all at the same time. So I expect there'll be like more flashing on the screen. Yeah, well, that's actually my next step. Did it run it all the browsers? I looked away when it did it. I'm not sure if it did. Yeah, I think it did. I just wasn't watching. Yeah, now it's running in WebKit, which is like a really weird looking UI on WebKit, very bare bones. Cool. So like we can see them running, which is fun. But again, even if the reason you were trying to see it was because something went wrong, that's probably not going to get you very far. What's a little more interesting is if you could actually go and debug the tests now. And again, there's tooling built into like VS Code, and you can test through there. I like to just launch it from the command line and do it there. So I'm just going to say, run that same test, but this time let's debug it. So I want to see what's actually happening. This is where things get pretty interesting. So even though like my test code is over in VS Code over there where I wrote it, it shows me inside a Playwright inspector. So it launched the browser, it launched Playwright inspector next to it. I can actually just zoom into the inspector here. And it has like these debug tools in it, and it shows me what line we're on. So it paused right at the beginning. It hasn't gone to the main page yet. So I can tell it to continue. We'll step over that. Now it's going to go to that page. And now it advanced to the next line in my test, the next like either action or assertion inside of my test. And it stopped at the click. But what's really cool is if you look at the browser over here, it highlighted it for me. So it shows me with a little red dot, and it shows me the selector at the bottom, just like it did when we were doing the Codegen thing. It's like previewing to me what it's going to do when I click next. So I can like really follow along now what's going on with my test as I'm debugging it. So I do that, I see the click, I see the next click, it goes to the next page, it finds the before button, it clicks on that. It asserts that this text exists, and then it goes and closes that and makes sure that it actually closed after. So that's like my whole test, but I was able to step through it piece by piece. It did that by opening Chromium and the Playwright inspector next to it, and just gives me control of the tests that I've written and lets me step through it and like visually see what's going on. And because it's Chromium, I can also press F12 and open up the developer tools and inspect the DOM while I'm in there working on it. So it's like super useful. And this is where, when I was saying earlier how Playwright provides you the tooling to understand when you do have a flaky test, what caused the flaky test. Having this kind of debuggability, if that's a word, goes a really long way in helping you eventually get to a place where you don't have those flaky tests. Okay, so let's take a look at what it looks like when we actually do have things that aren't working. We're going to go in here and we're going to make some changes. So first off, I don't like what's happening on the landing page here, so I'm just going to change the style. The PM actually came to me and said, it looks good, but can you make it pop? So my default to make it pop is just use that color because I'm not a designer and I have no idea what that means. And then on the hazard info page here, I'm going to look at my code, and there's this one place that looked like it was weird to me. It says like before dialog equals true, and you click on it, I'm going to change that to false. So that's probably fine. I'm just going to go ahead and commit this change to my repo. Forgot to create a branch. Test Tribe 2025. Oh. I have a very descriptive commit message here. I'm making it better. So that's usually what I'm trying to do when I'm committing code. And we'll head over to GitHub here. We can see my changes, and I'm going to create a pull request. Probably don't merge this. So we'll create that pull request. And I've already created some automated GitHub Actions workflows here that happen to go and validate my PR. It's going to go and run those tests that we wrote with that PR. We'll come back and check on that in a few minutes. Yeah, that's fine. First, let's go and run these locally. So I'm just going to do an npx playwright test again. So we saw the tooling around like how easy it is to get started with Codegen and kind of the tooling of debugging and all this. But what actually happens when a test is broken? And how do we, what information does it provide to help us to understand why it failed? I am not plugged in, that's why it's so slow. Let's just burn through our battery. There it goes. So I'm plugged into that, but I'm not actually getting any power. Okay, so the test ran, and if we look in where I ran it here, it says 2 tests failed. And I get it like a command line summary, but like that's kind of hard to read and understand what happened. But you'll notice that it immediately went and said, I'm serving out an HTML report at this address, and it launched it for me. So just locally, it went and created a report, and it opened it up in the browser for me so that I can go and see what failed in my test. And we can go and look at the accessibility test. So here we can see that, oh, assertion error, 1 accessibility violation was detected. Okay. And then it actually shows me all of the test steps that happened and where it failed. It takes a screenshot of it for me, shows me the screenshot, which is pretty cool. And then it has an attachment here. So in the case of the accessibility tests, it has this kind of text table thingy that shows me the actual things that failed. So it tells me the rule that failed was a color contrast one. So the foreground and background are too close, and some people aren't going to be able to distinguish read the text there because the contrast isn't high enough. And then it tells me exactly which element it was on. So I can see that it was, oh yeah, that's that paragraph that I was trying to make pop. Apparently I went the wrong direction with the colors. And you can kind of see that here in the screenshot, right? So that's pretty neat. All of that information available to me, but let's go take a look at the other tests that failed. When we look at the navigate hazard info, which was the one that we were watching with all the clicking, it tells me that it timed out after 5 seconds of waiting on this particular locator, the one saying practice how to drop, cover, and hold on. We expected it to be visible and it was not found. It tells me the line of code where it failed. That's cool. Shows me all the steps that happened and which one failed. Tells me how long each step took, which is really useful information to have. There's a screenshot like we had before. And there's this trace, which is interesting. So let's click on that and see what it looks like. So the trace is a zip file. I can download it and I can go to the command line and I can run npx playwright show trace and give it the zip file and it will launch the trace viewer for me. That's a lot of work. I could also just click on here and it'll launch it all for me because it's all just a local web app that's running. And this is my trace. So with the trace, I get a full timeline record of what the browser looked like at every step along the way. So on the left here, I have my actions. And I can go back and see, okay, I went to the main page and then I clicked on that link. And I went and found that other piece of text and I clicked on it. And you can see that let me zoom in because there's lots of different things on the screen here and this definitely works better on a large screen, but you can see that similar to that debugger that we were running, it shows me the action that it was performing. So I can see exactly the thing that it was trying to click on and I can walk through the whole thing. And this is like super cool because I can replay the whole thing and see exactly what happened at each step. And with each step, I can see what did it look like before the action or before the action, after the action, and what was the action I was trying to perform. And there's even more. There's the full console log of what was happening in the browser at the time. Apparently, I have a bunch of console errors that I should probably be looking at and warnings. There's a full network tab here. I can see all of the network requests that were made, the values that were returned, and like I can even filter down to just the fetches and HTML and JavaScript. I can click on them. When it's a fetch request, I can click on it and actually see the results that were returned, the response that was returned. Just like super useful information and makes it really easy to actually diagnose what happened when your test failed. So you get a flaky test run. If you have the trace, you can actually go back and replay the whole thing and see exactly what happened and fix the problem, hopefully. And this, when I first saw this, it kind of like blew my mind because this is the tool that I didn't really know I needed, but I very much needed with all of these tests that I had been writing. And then I clicked on something in here and I was like, oh, what? I right-clicked and I clicked inspect and was blown away a second time because it turns out that this isn't an image. This is an actual snapshot of the HTML at the time of that test. And this is all running inside the context of a browser. So I can actually go and inspect exactly what the browser looked like at that point in time and I have my full access to the browser dev tools that I would if I was just debugging this thing live, which is amazing. Like there's just so much information packed inside of these trace files and the tooling around it is just awesome. It's so much fun to play with that I am almost, not actually, but almost at the point where I get excited when there's a flaky test because it means I get to download a trace and start playing around with it, right? And the challenge previously has also been like, sometimes these tests would be flaky only in the context of running on your build server and not running locally. So like you couldn't even reproduce it locally to try to debug it if you wanted to. So let's go back to GitHub where I had my PR and I had the test run here. And we can see that the npm run end-to-end tests, so the thing where I go to run my end-to-end tests failed. Oh, it failed for a different reason because some environment variables aren't set. But the point was to be that the trace file would be attached here as artifacts. So that part of the demo failed because it hadn't run in a long time and something expired. But the trace file is just there for you. You can download it and you can replay exactly like I just did by opening up that trace file in the trace viewer and replay and find out exactly what happened with that particular failure. Cool. Quick break for questions. Any questions? Yeah, so the question is, can you use it for web scraping? So yes, you can use it for web scraping. There's nothing stopping you from using it for web scraping. There can be, I guess, like legal issues around that, so it depends what you're scraping. And in the past, in some places where I've worked on some web scraping things, you do sometimes get throttled. Like if it's a live website that you're trying to scrape, this kind of tooling will go faster than you maybe want it to, and that will cause the whatever system you're trying to scrape from to start to block you. So there are issues around that. It doesn't really have anything to do with this tooling. It definitely can be used to just like point it at a live website and go and do something. Yeah. I mean, yeah, so the question is like with the locators, how do you decide which ones to use, or like can you write logic to be more smarter about which ones to use at which point in time? Yeah, so you can the Playwright documentation is very, very good at explaining the recommendations of like what you should use for locators. The recommendation is generally to start by using the ARIA roles, so like the accessibility roles, so like get it by button or by get the header or get the input that has this text, because those are going to be the most reliable. You can fall back into there's like 6 different bullet points, I think, and you can go down to like just doing CSS selector level locators as well, and we do often end up having to do that. Yep.
How easy is it to take the test that would run in GitHub Actions and run it against our staging environment?
How easy would it be to take the tests that would run in GitHub Actions and run them against your staging environment? Yeah. So that depends a lot on your environment, I think, is the thing. Yeah, so from Playwright's perspective, pretty easy, because all it needs to know is what URL to point to. But what's probably going to be challenging is how to do it securely and manage your credentials properly. So like what I'm doing in this example is my credentials are stored in environment variables. And I set up those environment variables before I did the demo. And with GitHub Actions, they're stored in secrets. And because that part of it is actually testing a real staging environment of our auth environment. So the auth credentials are stored in secrets, and it uses that to go and do the actual login. So it depends, but I've definitely heard of a lot of teams that they'll have a suite of tests that will run against like their local dev environment for testing all of their changes, and then they might have like a subset of the really important core tests that will run against their deployed environments, like staging and production after each deployment, to make sure that those are right. And it's the same test, they're just pointing it at a different location through configuration. Yeah.
Other questions?
Thanks for the presentation. It was really interesting. My question is around the state, because you mentioned that we can run the test in parallel and we can isolate, but at the same time, sometimes we have some difficult situations. So, for example, if we can't just, create a user for each of the test scenarios, and then if the tests are run in parallel, and if this and these are web tests, so then we change the state of the application, and it can be persistent. So, for example, database or whatever. So then my question is: are there any built-in mechanisms in the Playwrights which allow us to make the tester work easier manipulate state easier? And the second small question is, you mentioned that it's 1 millisecond when the browser, let's say, instance of the browser start to execute tests. So so we all know that browsers are pretty heavy. So there are different ways how you can make them to start up faster. So for example, remove all the extensions and maybe just do some other magic in terms of the profiles. But then my question is, what makes these instances to start up faster from the how the Playwright is built?
Yeah. So on the how is it so fast at creating browser contexts, I don't know because I haven't looked at that part of the code. But one of the things that makes it a little bit different is that like it's not running your instance of Chrome that you're using in your desktop. It's an instance that's just for Playwright that's installed in a specific location. And in this case, it's you can test it with like full Chrome. I'm testing with Chromium, so it's like doesn't have any of the Chrome stuff in it that calls home, and so it's like very stripped down versions of the browser, just like the strictly open source version of Chromium, and that is in itself much faster. And I think they just basically have it configured in the fastest possible way to start it up. Your other question around isolation, state management and isolation across the tests is a very hard problem to solve, and it's going to be very specific to your application, how you decide to structure that. There are some built-in features with Playwright that can help, but you should probably use them sparingly, I guess. But I wouldn't recommend doing this for everything, but in scenarios where there's high contention on state and you want the test to run purely in isolation, if you're willing to take the trade-off, you can just intercept the network request in the test itself. And I do that in this test because I'm cheating a little bit. But you can tell it like when the web application makes a call to this particular URL or a URL that matches this regular expression, return this instead. And that makes it run really fast, and it makes it very repeatable. And it means that it can't really conflict with like things that other tests are running at the same time if you have multiple tests hitting the same environment at the same time. Also really, really useful for testing error scenarios, because another thing that traditionally is very hard to do is I want to test what the UI does if I call this API and it crashes in the backend. But like, how do you make your backend crash on demand? That's hard to do. So you can just intercept the request and tell it when you call this API at this particular point in time, return a 500 and see what the UI does. And then you can test that the UI responds to that the way you want it to. So that's one tool that you can use. But mostly the isolation piece, the state management piece at the data side of your application is hard. We usually try to do it so that whatever the test is that I'm running, it creates some test data that's just for that test run for that user. And hopefully that's something that doesn't like interfere with the other tests. But that's a hard problem to solve. There's different problems too around like if you're wanting to run it, not just like have multiple tests running at once, but you don't want the same test running against multiple browsers, right, at the same time. You want that to fan out and be fast. So you want to run them in parallel. One thing that you can do is have, if you're using like GitHub Actions or Azure DevOps pipelines or whatever, you could have that fan out to multiple instances. So you could have an actual like full test environment for each browser that you're testing and run them in parallel on different machines entirely. So that's like a strategy. But there's a bunch of different strategies around how you can tackle that. None of them are easy. That's like one of the hardest parts still of running tests. So I'll pause on questions now. We'll come back to questions. I have like a couple other things I wanted to show. Yeah, so there's this other new thing that was released just in like the latest version of Playwright that I think is super cool. And it kind of goes back to the accessibility testing that I talked about before. So I'm going to launch the Codegen tool again. And we're going to go to that welcome page because I have this one test and it's kind of weak, to be honest. This one here that just says the welcome page loads. All I'm doing is going to the main page as a new user and making sure that it went to a page called welcome, or that the URL changed to a page called welcome. That's like, didn't do much, right? So we're going to launch the Codegen tool and take a look at a new feature here. I wonder if I can get power somewhere else. Okay, so let's go localhost 8080 again. So there's a new type of assertion here. Oh, I still have my poor accessibility. There's a new type of assertion that they added in Playwright 1.49, and it is called this one here, assert snapshot. So I'm going to click assert snapshot and click on this. So if you've probably heard of snapshot testing in the context of end-to-end tests before, but it was in the context of it would actually compare a snapshot of like an actual screenshot of what the screen looked like. So it would take a screenshot of that and you would say, basically you would be saying in your test, I expect the UI to always look like this. And if it changes, crash the test because I like fail the test because this isn't supposed to change. And I want to go and make sure that it changed, if it was supposed to change, that it was supposed to change like appropriately. And then I would have to go and update my snapshots again. I'm not a huge fan of snapshot testing and that style of snapshot testing. You can still do that with Playwright, the screenshot-based snapshot testing. But I feel like anytime I've attempted that, I end up just going and updating my snapshots all the time because like we're changing the software. The UI changes and that's normal. And we don't necessarily want that to crash. So there are exceptions to that. Like I also, one of the things that my team works on now is the design system for our UI. And we do have snapshot testing in place for like the individual components of those because we want them to look a certain way. And sometimes people accidentally make changes to CSS files that change the way it looks very drastically, and we don't want that. So we do have that kind of snapshot testing in place. But this is a different kind of snapshot testing. So it solves a problem that I've always had, which is like, what do I actually want to test when I go to the page? I want to test that there's certain things there, but like, if I go and list out write assertions for all of those individual things that are on the page, it's a lot, and it feels like it's going to be a lot to maintain. And I don't necessarily want everything. I just want like parts of it. So they added this feature called ARIA snapshot testing, and what it lets you do is, so it generated it for me here, and I'm just going to copy it into my actual test. And we don't necessarily have to run this. I can just kind of explain what it does. But so what I'm saying is I go get by role main, so find the main area of the site, and to match this ARIA snapshot. So I expect it to have an image called 2 weeks ready backpack logo. I expect it to have a heading, welcome to 2 weeks ready. I expect that heading to be level 1, not level 2. And then there's this paragraph with all of this text and a next button. So it's like a kind of nice text-based overview of what the UI looks like from a accessibility tree point of view. So the accessibility tree is something that is kind of a view on top of your application that systems understand and people understand who are using like screen readers, that kind of thing, that describes the UI to you. So if you're using a screen reader, you could navigate through the accessibility tree, and people are really good at doing this, to navigate through your site and understand very quickly what is being represented on the page without like visually being able to see it. Now, if we were always just testing the full ARIA snapshot of what it looked like, that would be a lot again. But this actually allows us to just do partial snapshots. So I can actually take this whole, I can take part of the paragraph out, or I can take the whole paragraph out, and maybe I just want to say that I expect the welcome page to have our logo image. I expect it to have a heading that says welcome to 2 weeks ready, and I expect it to have a button that says next. And now that's my snapshot. It does partial matching on the snapshot. So I can go and change other things. I can change visually what it looks like. I can move things around a bit. As long as the accessibility tree matches this still, my test is going to pass, which is pretty cool. So let's just see if we can run it real quick, if my tests will run in a reasonable amount of time. Welcome.spec.js. Playwright test, welcome spec.js. So this should pass. And I could go but like I still might change some of these things. Like maybe I come in and I change this to be 2. Oops. Where's my heading? Maybe I change this to be like 2 weeks ready instead of the number 2 weeks ready. Oh, it's not passing because my accessibility changes are still in there. We should take those out. So this should fail now because I did change the heading, and that's one of the things I'm testing in the snapshot. See that it failed. It gives me a nice overview here of like where it matched and where it didn't match, which is cool. I could go and manually update that, but if a bunch of changes happened, it could be hard to do that, right? So I can also just run update snapshots. And that's going to run the tests again for me, and it's going to fail still. But what it's going to do is it's going to give me a Git patch file that I can review and apply to my tests, and then it will just like automatically update that part of the snapshot that needs to be updated to match what changed. It's also, you can also use update snapshots in this same way. Oh, that actually passed that time. That's weird. Why did it pass? So what it will do is inside your test results folder, give you a patch file here that tells you what you need to change. And this is an old one, which might be why that demo didn't work. But if you're getting started with this ARIA snapshot testing, what I was just going to mention is you can go through and just put in a bunch of empty to-match snapshot assertions wherever you want to do it in your code, and tell it, run the command to update snapshots, and then it will go and fill those in for you with what the snapshots are. And then you can just take out the parts that you don't want so that you just have the partial pieces. So really easy to get started again with ARIA snapshot testing. I think it's just like a really nice, concise way to describe what you're expecting to see on the page without having all of that toil of like constantly having to update your snapshots every time you change your UI a little bit. There's a bunch of other new stuff inside of Playwright that we won't have time to fully talk about, but there's a few other things I wanted to quickly cover that weren't demo related. There it is. I'm going to stand up, sitting for a while. Okay, so we talked about pipeline integration, and we showed a GitHub action that didn't actually run as expected, but you would be able to just download the trace file was the point of that. If you're using something like Azure Pipelines, there's also integration there because it shows the test results. So you can actually dive into individual test results. So that the actual test that failed, you can click on it in like the UI of the test results pane and download the trace files and screenshots just for that test that failed, which is pretty cool. We are going the wrong way because I'm holding this backwards. We talked a little bit about isolation strategies already. We covered that with the question. What we didn't cover is kind of like how you actually design the test code itself. We were just using pretty basic tests where we were just using the output of the Codegen tool. But there's a really nice design pattern which you absolutely should look at if you're doing this at any kind of scale, which is the page object model. Really good documentation on the Playwright website to guide you through how to use that. But it allows you to basically structure, create a code representation of each of the pages that you're testing, and put those locators inside of that page object model so that you can reuse them across all of your tests instead of like rewriting it all over the place inline in each of the tests. And the debugging and everything still works fine when you do that. So there's no reason not to. It just makes it easier to maintain your tests over time. We talked about ARIA snapshot testing. Component testing is something else that's, I think it's marked as experimental, but I'm kind of interested in this one. In today's talk, we were talking about end-to-end testing, but there's also like the unit testing aspect of testing like web components, the smaller pieces of code that we run in our web applications. And this has traditionally been kind of a tricky thing to do. There's the way the industry has generally solved this in the past is by we want those unit tests to run like really quickly, so we run them in the context of in Node.js in something that like simulates the browser but isn't the browser, and we do that so that they can run really fast. And they use packages that, as I said, are like simulating the DOM in the browser. But it's kind of a weird thing, and what I've found at any of the places where we've done this at scale, where there's a lot of tests, we end up being in a situation where we're actually doing more of just testing that package that's simulating the browser to see how good it is at simulating the browser, as opposed to actually testing our components. So there's this effort within Playwright to allow us to test like React components and Vue components and other popular web framework components inside of Playwright, where it's using it in a real browser, which is good because that's where the code is actually going to run. It's not going to run in Node.js in a thing that simulates the browser. It's actually running in the browser, so let's test it there. So that's like something to kind of watch out for. And there's also a Playwright's testing service that runs in Azure. I don't actually know a whole lot about it. I just haven't had time to dig into that thing, but I thought I would mention it. Cypress has a similar thing, service, right, where they can run their tests, and you just like give it your tests, and they'll run it in their systems, and they'll fan it out across machines to run faster. This is like the Playwright version of that, basically. That's all I had for today on Playwright. As I said, the documentation is phenomenal, and I just kind of gave you a little taste of it here. If you like what you saw, go check out the documentation and learn more and give it a try. And now we have time for more questions if people still have some questions.
Thank you, Dave, for the presentation. It was
Yeah.
really cool to actually today. A couple of questions. You said that this tool supports different code language like libraries.
Yep.
Are they updated all at the same time?
They are, yeah.
Maybe one or two of them are a bit outdated. And, because, for example, for Selenium bindings, like the Java bindings, they are updated like all the time, but the C# bindings, for example, they are a bit late normally. Yeah,
these ship at the same time, so it's all the bindings are all maintained by the same team, and they all ship at the same time. Yeah.
Yeah, and another question. So you said that it's possible to capture the screenshots. Is it possible to capture video?
Oh yes, I forgot to mention that. So I was really excited when I saw like the capturing of screenshots and the capturing of, you can do recordings as well. So you can configure it. We didn't really look at my global setup and configuration for these tests. But again, it's all on the documentation site anyway. You can configure for each of the screenshots, the recordings, and the traces. You can tell it to capture those all the time for every test. You can tell it to capture it and only keep it if it fails. So it'll capture it and then just like throw it away if it succeeded. Or you can tell it also to, if the test fails, run the test again and then capture those things. So like you have these options on how you can configure it to record those. With the Playwright trace being available, I haven't really found as much of a use for the recording anymore. because the trace is like the recording, but with all of the information I need to know to actually debug it. But yes, you can do recordings as well.
Thank you. And another question, can you interact with some browser data? Like you said that we can see the network, for example, in trace,
Yeah.
but can we log the network requests or something?
So
local storage or something like that?
It logs them in the trace already for you. So it logs the request and the response and everything in the trace.
Yeah, I said that if we can access it in the scope of the test, for example, can we verify
Yes, yeah.
the
you can. So
response of the API that
so
application has?
I talked about the network interception, and I kind of framed it around the context of intercept and like return something different. But that's just one use case of network interception. You can also do network interception and just assert that a certain thing happened. So you can just like inspect what happened as part of the test, and it's the same API as doing the interception, where you like you basically hijack the request and return something else. You can also just peek at the request and say, make sure that it had this thing that I'm expecting it to have. Yeah, same feature. Another question over here. Yeah, you're welcome.
Thank you for the presentation. It was really interesting. At the beginning of the presentation, you mentioned that there is a big difference when switching the, let's say, not Cypress, but Selenium to the Playwright, in terms of that all this, like Playwright has better mechanisms to avoid the flakiness of the tests. So I'm wondering how technical this has been done, because in Selenium you still can have all of these listeners, and when they're not working, you can use some timeouts or other mechanisms to make it work, especially when you're using page object model. So you can kind of encapsulate all this functionality into your page object model, and then use high-level function calls for making your tests really readable. So then the question is, what are the internal mechanisms which allow this to function better compared with the case when you add this functionality to the Selenium, to the page object model function calls?
Let me see if I'm I think you're asking me like, how is it different than just having like a really well-structured Selenium test? Like what technically did they do to make it actually less flaky and better than if we just actually wrote our Selenium tests better?
Yeah, I mean just so that you mentioned that one of the selling points of the Playwright is that it makes the flakiness less.
So part of that is just that it's built in, and a lot of those things that you could do with Selenium if you did it a certain way were there. It's just built in. But I don't know the technical details of the implementation, but my understanding is that it's the implementation of how Playwright interacts with the browser and actually does the automations is closer to like the native browser implementation of those input pipelines and events that it listens to for when it's ready. And that in itself reduces a lot of the flakiness that we had with Selenium, and just its architecture of how it decided to like try to drive the browser. And that's just a factor of like when these tools were built and architected. And then the other part of it is just that because the locators have all of the await and retry pieces built into it already, you kind of fall more towards the pit of success with how your tests are designed, and they'll run faster and more reliably because of that than if you did like the more basic type of implementation that you might do in a typical Selenium test. So it's definitely still possible to write like tests in Selenium that are well structured and have a lot of retry. And the previous team I was on had like a pretty good suite of tests, but the amount of infrastructure they had written to have all of that like auto retry and await pieces built into those tests was like, that was a lot of code that we had to build and maintain just for our particular test suite. So you get that for free now, basically.
And one more question, sorry. How good or stable Playwright is in testing the React-based apps when we have always our DOM rendering and our elements became stale, and it's like a huge pain in Selenium, for example, when we have all the time elements are not connected to DOM anymore, or we have our virtual DOM, and like how
Right.
Playwright do?
Yeah, I think I know the problem you're referring to. So it's like you got an instance of an element and you go do an assertion on it and the element doesn't exist anymore, right? Or it's like, yeah, it's been re-rendered as something else. So very good question. And that actually goes back to the core concept of Playwright, which is the locator. So when you use a locator, you say, get element by a test ID or get it by aria role, whatever. So let's say I'm getting the button with the name OK or save. And I even have like a variable. I say var button equals get by locator button with name save. That's not an instance of an element at that point. It's an instance of the locator. And anytime you go to perform an action or an assertion on that locator, it reevaluates against the DOM to find what's actually in the DOM that matches that at that point in time. So you don't have this issue where you have like an instance of an element and you're trying to assert it, but the DOM has gone and changed and it's in a different state now, and the thing that you're trying to assert is like maybe even garbage collected or something in the browser. So as long as you're using locators in the way that they're intended to, you won't have the problem that you described. You can still write tests in Playwright where you go and get instances of elements. It's not a good direction to go. That exists mostly for, so there's almost one-to-one API parity with Puppeteer in Playwright. So you can take your Puppeteer tests and basically just require Playwright instead of Puppeteer and have it run. And now you're running in Playwright. But you're still going to have like some of those issues that you talked about, because they're mostly dealing with like, go get me an element. Now I have the instance of the element and do some assertions on it. And that leads to flakiness in itself. And so that's more of like just a stepping stone. And then hopefully you refactor your test to use locators, which eliminates the problem that you described.
Thank you.
Yeah. In terms of a snapshot, I'm curious that how Playwright can handle different platforms. So for example, run on desktop or run on mobile. Is there any variance for the snapshot that Playwright will capture and will associate with each platform when they check the snapshot?
Yeah, so I think that I actually haven't done that, so I don't know for sure. But I think that what you can do is you can have the snapshots like per browser configuration that you're running. So you could do a snapshot like for your emulation of a mobile device where you're just setting like the screen size to a certain thing, or a snapshot for WebKit and a snapshot for Firefox. That's how I think it works, but check the docs because I haven't actually tested that to see if that is how it works. But yeah, that's my understanding.
I also have another question. Let's say that we cannot capture any element on the web application. So which method we should use in Playwright to, like, for example, we want to click on, they have a possibility to click on the picture as the location, like the coordinate X and Y.
Oh, I see. So you can still simulate mouse events through the APIs that you have. So in that case, what I would probably do is try to find like, there would be some element in the DOM that would be like the parent of these things, and then do the mouse interactions relative to that, like at an XY coordinate. That's how I would approach it. Yep. Lots of questions.
Yeah, I just have a question. How we can see the browser version, and how often the Playwright install the browser version?
Sure,
Because,
yeah. So how can you see what browser version is running for the test, and how often does it rev the version? So the version, I think you can override what version it uses if you want to, but each version of Playwright has a version of each of the browsers that it's going to use. So when you look at the release notes for every like major and minor release of Playwright, it tells you what version of the browsers, of those browsers that it updated to. So it gets installed on at least on Windows into the user local storage path for your user profile. So it gets stored in like just a folder in your data folder. It downloads them from blob storage somewhere, pops them in there, so you can always go and look at what it's using. But basically, every version of Playwright is tied to like the latest version of those browsers. Yeah, yeah. So it's good practice to like regularly, maybe once a month, just keep grabbing the new version of Playwright to make sure that you're testing with the latest version of the browser. So it defaults based on the Playwright version. I think you can override that if you want to. Like you could tell it to use a specific version, but with browsers these days, it's kind of like users are always on the latest, and that's what you're trying to support. So what I've done is just like every couple of sprints in our cadence of how we do development, I'll go and update the version of Playwright that we're using. Oh, that's a good question. So when there's a new version of Chrome, how quickly does Playwright ship with that new version of Chrome? I've never actually looked to see. I will say that I've not had the problem where I've been running Playwright on like really old versions of Chrome, so I think they're like pretty up to date with it, and they ship like every month. So I think they're basically always on latest of all those browsers, like within a month anyway. Oh. Question over here.
Thank you for your presentation one more time. So as far as I understand DevTools protocol, in comparison with Selenium-based tools, Playwright has a huge limitation of testing native mobile applications. So are you familiar with any plans of maybe extending this? I mean, not testing in like mobile resolution.
Yeah.
Yeah.
You know, I haven't looked or heard if that's something that's on their roadmap. So the idea being like actually testing on native mobile devices. Yeah, I don't know. Sorry.
No problem.
I'll try to find out.
And coming back to snapshot testing and screenshot comparison testing, so canvas element. I do have plenty of geometries displayed in canvas element, so the only way I found to test this is to compare screenshots, which really flaky. So are you familiar with any instruments of Playwright that could help with interaction with canvases, or still screenshots are the same, the only?
Yeah, I think for screenshots it's still the same. You can set like a tolerance level sometimes, but like when it comes to pixels, that's really hard to know.
Setting some thresholds, not the pixel amount, but still they are really unstable.
Yeah, it's a hard one, which is kind of why I steer away from it as much as I can. But
okay, thank you.
Yeah.
Thank you very much. Hello, Dave. So, quick one. Is Playwright the go-to testing development suite in Microsoft? And will it be also? Can it be also used for like AI testing, or right now it's just web and mobile?
So what do you mean by AI testing?
Okay, so like say you have a model or probably your data engineering tests, your pipeline tests, would it be something, can it be used for that right now, or would it be pivoting towards that?
Yeah, I don't know if it's the right tool for that. Like it's really good at testing anything that has a web UI or anything that has a REST API. You can use it to test those things. You could test your model through those mechanisms. I guess that would be okay. But yeah, I don't know what the right tooling is for testing AI models. The other question though is a really interesting one. So is this the go-to tool for testing at Microsoft internally? Microsoft is a very big company with a lot of products and a lot of history. I would say, yes, it's the go-to tool for any new testing that's happening. But even on my product, which has probably like 15 years of code in it, give or take, there are many iterations of test tools. So right now what we're working on doing is getting our Puppeteer tests. So any new tests that we write for end-to-end testing is done with Playwright. We're working on getting our existing Puppeteer tests migrated over to Playwright. And then we have a whole bunch of other tests on even older technologies that we're in the process of evaluating. But yeah, with these really big products and a lot of history, you tend to have a lot of different technologies in play, even for one version of the application. So yeah, I would say like most products that I've interacted with that are doing end-to-end testing, all their new stuff is written in Playwright. There's also a lot of like legacy Puppeteer and other tests as well. Okay.
Can you please tell us about what you don't like about the Playwright? What is the worst pain of this tool?
What don't I like about Playwright? I would say that at scale, when it comes to having a lot of tests over a very large product, even though it's faster than other things, previous iterations of these test frameworks, it still is slow. Like it takes a long time for a large test suite to run. So that's, I would say that's probably more of a like end-to-end testing thing in general. That's a challenge. In terms of the tool itself, I have been so focused on the things I love about it that I have not thought about this very much. To be honest, like I just don't have a lot of those like big friction points that I had previously. I don't have with Playwright, so it's just not that we've run into. No. The bugs that we have are, I would say, more in like our own software that we're trying to test. So we still do struggle with the whole like isolation thing, right? So making sure that every test that we write is something that we can run over and over and over again and in parallel and not have any tests trip over each other is still like a huge challenge. And if they could magically come up with a way to solve that, that would be amazing. But it's pretty application specific. So that's probably like our biggest pain point still. Yeah.
Why don't Playwright support to test on native app or on mobile?
So because the tests run, so when you're running Playwright, the code is actually interacting with the browser that's like on your machine. And if you were testing mobile, that now has to be controlling like a browser that's running on a different machine and in a completely different style of operating system. So it's just like not been their focus, I think. But as I answered earlier, I don't know if it's something that they're working on and what's on the roadmap, because I haven't really looked at it. It's not like a big priority for my product either to test those scenarios in an automated way. But now you all have me very curious, and I'm going to go and try to find out what's on the roadmap, and I'll reach out to the PMs and see if they can share anything. Cool. All right. Thanks. You do?
Yeah, it's better for me. Like I can scream, but I don't think that it's a good idea. Yeah, so a huge thank you to Dave for all of the presentation, despite the winter inside here when we have a Chinook outside. Yeah, so hopefully you're all be good with all of this thing. And guys, that was a really great questions. Like, yeah. I'm really enjoying like listening. Like I was thinking about, okay, what else? What else can be asked? Like so, yeah. Thank you for that. And regards to our traditions, we are thanking our speakers. So we are continuing our tradition on presenting a book. That's one of the things. And regards to the new traditions that we started only on our first anniversary is to giving certificates to all of the speakers as a certificate of appreciation to a speaker who gave so much knowledge and impact to the Test Tribe. So thank you very much for the impact you have. Yeah. And thank you all. We have some more time, and I would say we can wrap up. The only thing I would ask, we have a tradition to make a group photo. So please, let's make it, I think here, but I'm not the good photographer. So if anybody has like propositions, other propositions, that's totally fine. Yes, I'm happy about that. So yeah, let's do a group photo. I will take our banner and thank you all. Let's meet in February with a better inside weather.